All right, so today we are still a part of the collecting and organizing our data into different types. One of the ways that you can display your data outside of doing a frequency table or distribution is by using histograms. Okay, a histogram basically is similar to a bar graph, except your bars touch each other. Okay, except for the fact that your bars touch each other. Okay, that is what a histogram is. So it looks like a bar chart, but again, they touch each other. And so here you have this distribution of time to a certain number of visitors that came to whatever the location is between these different intervals. Okay, and so when you are creating your histogram, you want to make sure, just like when you're doing any type of graph, that when you create your axes, you want to do what with them? Label. You want to make sure that you label, okay? And considering that we are dealing with time here, it starts at 9 o'clock. We don't have any negatives, and all of our number of visitors are positive, so we're only looking again at a positive axis. And then you pretty much just create a graph. All right? So, how are we going to label our x-axis? Time. And our y-axis? Number of visitors. Just like when we do any other type of graph, we want to make sure that we label our x and y axes. And then we want to create a scale for our time as well as our number of visitors. When we look at our time, we go from 9 to 10 to 11 to 12 to 1300, 1400, so on and so forth. Do we skip any times? So what would be a good scale for our x-axis? By ones, okay? Now, when the x and y axes intersect, what point is this? 0, 0. So we don't want to start with 9 right here unless we include a break. You guys remember that from your years of doing graphs from maybe elementary school? A break, okay? If you don't know, whenever you are starting far enough away from 0, you want to include a break. So then that indicates basically between that space, we have 0 through 8. And then we're starting with 9. You don't want to have your graph, if this is 0, then you have 9 right here, because then your scale goes by ones and it's not even. But if you include the break in your graph, it indicates that I'm not using this space because I don't need the time 0 through 8. I'm starting at 9. Then I can keep my scale consistent. So 9, 10. Let's use this a little bit better. Do you guys have the same amount of space? Could I skip a line and still fit all my times?
You need one more thingy.
I need one more line?
Yeah, but it's fine. Like, it looks better than squishing it all together.
Okay, well then let's do it like this. You said I need one more line?
Mm-hmm.
Okay, so then I'm going to start 9 right at that point. So then I can skip.
That's right.
No, I'll still be short one. So. When I look at my y-axis, my lowest value is 250. My highest value is 563.
I thought the lowest was 232.
Sorry, 232. Thank you. How should I do my y scale? Bless you.
By 20s?
By 20s? Every line by 20s? I don't think it'll fit.
Wait, could you do like your range divided by how many lines you've got?
You can do it that way. How many lines do I have and what's my range?
But wait, for the y-axis, are you gonna do that break thing again?
I definitely want to do the break, for sure.
12. If you're not including like the very top, good. Including the very top, that's fine.
So how should I scale it? How should I scale my y-axis? When you're creating it yourself and there's no specification on how you need to divide it up like this one, it's your choice. Just like when I asked you to create a histogram with your data, it's going to be your choice on how you label it as long as you make sure you label it. Now to create your histogram, like I said, you pretty much are creating a bar chart where the bars are touching each other. So between 9 and 10, I'm at 324. For me, I decided to scale it. Every other line was by 100, so pretty much every line goes by 50. So then 325 or 324 would be right below, halfway between 300 and 350. And I create my bar between 9 and 10 at 324.
Now, because it says less than 10 and not like equals to 10, does it need to make it a little bit before
Because these here, they are the exact same. Your upper limit is the exact same as your lower limit of the next class. You will draw it on the actual line for 10. Because when you do the next class at 356, it's going to be an extension of that line for the next bar. So these should be actually at 10, at 11, at 12, and so on and so forth. So based off of your scale, how you scale the y-axis, you should be drawing in your histogram bars. So again, depending on how you scaled yours, that's how you're going to be drawing in your bars. This is how mine would look based off of my scale. Yours will probably look somewhat similar, but the one thing that's consistent for us is that our bars should be touching. There should be no gaps if you are creating a histogram. And that is how you create a histogram, okay? One of the questions that was asked was, what if you have a 0? Like one of your entries in your frequency was 0. Well, then you'll just have a space within your histogram. Okay? In that particular case, those bars won't be touching that 1 because of the 0. Okay? Hence, in your project, depending on the number of classes you have, if you do have a 0, then when you draw your histogram, it's going to look a little odd. Okay? It's going to look a little odd. Questions? Now, Eric had asked, because this was less than 10, should we be a little bit before? And I said, because the upper class and the lower class were equal, they were at the same value, that just meant that the bar was going to be shared by the bar of the next class. However, when it's not the exact same, such as this one, the shoe size example, you are going to have to do something a little bit different. Okay? Because you are creating a histogram and not a bar graph, histogram bars need to touch. If you try to draw these bars stopping at 19 and starting at 20, you're going to have a gap. So to prevent that gap, what you do is you basically find the halfway point between the upper class, the upper limit of your first class, and the lower limit of your second class, and find that midpoint. What's the halfway point between 19 and 20? 19.5. So when you draw your bar, it's going to go to 19.5, and you'll start your second class bar at 19.5. So you won't go to 19, you'll go to 19.5. What about for this, the second class? What's the halfway point? So for your second class bar, it's going to go all the way to 24.5, and then the third class is going to start at 24.5. Keep going. So you'll go to 29.5 and start at 29.5.
Doesn't that mess up your frequency?
No, because based off of this, we do not know what our raw data is. Okay? And because of that, we're able to do as such. Now let's say for your for you and your heights and your shoe size. If you rounded your heights to 3 significant figures and you did something of a similar nature, your frequencies are not going to be adjusted because you rounded. Mm-hmm. And so at that point, we're no longer looking at the decimals, we're looking at the whole number.
So when we make a histogram for our data, is it easier to round it up and do that?
You're talking about your data 3
Like
significant
for the
figures?
heights, yeah. Would it be easier to round it up when we're making histograms?
And that's up to you. It really is, and that's how you scale it. But one thing I will say is that if your frequency table looks like this, there's a gap. When you create your histograms, you're going to need to do this, what we're doing right now. However, if there was the overlapping like this, you won't have to. Does everybody understand that? You sure? This is usually where students lose points in their projects and also on quizzes when you get a frequency distribution that looks like your shoe size. You'll have gaps and you should. Question?
I don't use breaks in the end.
Yes. Let's finish this off. This one is 39.5. And because this applies to basically the middle of our data, it also applies to the beginning and the end. If there was another class of shoe sizes, it would start at what? It would start at 45, which means that the upper limit of the very last class should be
44.5.
very good. Look at the beginning. If there was a shoe size class before 15, the last one would have been 14, which means the lower limit of the first class should be.
14.5.
So it applies to the beginning and the end as well. Okay? So let's make our chart. Let's make sure we label our x-axis. How? Shoe size. And our y-axis. Now we need to make sure that we scale this. How should we scale our x-axis and our y-axis? You guys want to do our x's by 5s?
Sure.
Okay. I'm not going to include a break for this one.
Do we skip a line so that?
Well, let's see. 5. Well, if I do a break, let's see. 15, 20, 25, 30, 35, 40, 40. Well, yeah, that was it. Okay. Never mind, I will do a break. So I won't be bunched up like this.
So what if the 3 and 9 mixed up?
That is your frequency. That's for your y-axis. So I need to create a scale for my y-axis. This is just my x-axis.
Could we like,
You sure?
yeah, I was gonna say could we skip a line, but you already did.
What about for my y's? How should I scale my y's?
My 3?
It won't fit. It'll finish at 39.
As if I do every line?
Yeah.
Okay.
I would do
5's every line or skip a line?
Wait.
You'd have to
You
do
can-
every line. I don't think it fits every line.
10, 15, 20, 25, 30, 35, 40, 45. Yeah. The same thing that we're figuring out on how to graph this is going to be the same thing you're going to have to do when you create your histograms. Okay? And the thing is that if you notice, we're using over 50% of our graph when we're doing this. Oh, I am using over 50% of my graph, close to 100. You guys should be doing the same. Okay? You have all this graph paper, use it. So now when I create my bar, the lower limit of the first class is going to be at 14.5. So that's going to be before 15, and then it's going to end at 19.5. So in other words, right before 20. Yes?
I have a question. If we want to rewrite our x-axis as like, but then having it right before like 15, right before like 20 and all that, we just make it 14.5 and like 19.5. It's like 5 there. Just so we're not before the line.
I see what you're asking. I mean, when you create yours, I mean, you can do that, but I mean, you can do that. I mean, I wouldn't do that because it's showing that you understand how to use these types of frequency tables. But I mean, if you're creating it yourself, then that's a little bit different. So, yes.
So I'm a little confused. Like, you don't have to start your graph at the lower class name.
That's what he was asking. You talking about why not have it at 14.5 on our scale? That's what I was saying. Like, if you're creating yourself, I mean, you can, but realistically, like, if I didn't tell you that, you would have started yours at 15, wouldn't you? Mm-hmm. Exactly. But I mean, if you're creating yourself, I mean, I can't stop you and say, like, no, you shouldn't do that. Is it done normally? No, it's not. It really is not done that way. It's usually done in whole numbers. Okay? So, like, if I give you a homework question and the scale is already there, you're not going to just scratch out what's already printed and change it to 14.5. No, you're going to go right before 15 and draw your bar. You see what I'm saying? And so, when you're creating yourself, I mean, I can't stop you if you want to use 14.5.
Why do you need the 14.5?
Because if you don't, your bars are not going to touch. And the proper way to create a histogram is by using the halfway point between the upper limit and the lower limit of neighboring classes. Question?
You won't have to worry about this if you did it like the last graph.
Right. Now, you won't have to worry about this if your frequency table overlaps. That's why, I was like, there's a difference between having the upper class and the lower class overlap versus there being a gap. And it also makes a difference when we do cumulative frequency curves, which is what we're going to learn next. So if they overlap, you don't have to worry about this. This is the only time when you do have to worry. All right, so right before 15 and then right before 20 at a height of 3. So right before 20 and right before 15, you have a height of 3. Right before 20 and right before 25, you'll have a height of 9. And so on and so forth. So you guys should be getting in this graph. All your bars should be staggered a little bit before your 20, your 25, your 30, your 35. When you do your histograms yourself, I hope that you'll use a ruler so your bars can be nice and straight. Not like the ones we're drawing by hand right now. Looking at the last one, are we going to need upper, lower boundaries? Or are we going to have overlaps? We have an overlap here? No, we don't. So we are going to need the upper and lower boundaries of each class. That's what they're called. Okay? So like here when it says write down the lower and upper boundaries of the fourth class, well, your fourth class is 1, 2, 3, 4. It's this class right here. It's basically asking you where are the histogram bars going to be for this particular class. What will be your lower boundary here? 15.5. What will be your upper boundary? 20.5. because it is the halfway point between the upper limit and the lower limit of the neighboring classes. So they're called boundaries. Questions? Yes?
You know how right now the graphs are whole numbers? Will we ever get one where they're already written as 0.5 and we have to find the lower and upper boundaries of the 0.5?
It's a possibility, but all we're doing is pretty much to find 20.5, you would just add 20 and 21 and divide by 2. So if you're ever presented with something that is like a decimal, you just add the 2 and divide by 2. So you're finding the middle. Okay? So you'll have to create the upper and lower boundaries for all the other classes to draw a histogram to represent this information. Questions here? Okay.